Hello everyone. This video will cover the second problem of the USACO 2020 December contest. So the problem is daisy chains. And here is the abridged problem statement. You're given an array of n different daisies of arbitrary values. So let's use the sample as an example. Let's say you have 1, 1, 2, 3. And now a photo is just some contiguous segment of daisies. So for example, this is a photo, that's a photo, this whole thing is a photo. Your photo could also be like from here to there, and so on and so forth. And now you want to consider for each photo, you take the average of all the flowers, and then you check if that average exists in the photo. And if it does, then you increase your answer by 1, and you want to count how many photos are there such that the condition is met. So what I mean by that is, let's take this photo for example. From 1 to 1, the average is going to be 1. Is 1 inside the photo? Yes, it is. So we add 1 to our answer. On the other hand, if we consider like this photo, the average is 2.5. 2.5 is not in the photo. There's no flower with 2.5, so we don't add 1 for this photo. So how do we solve this problem? Well, this problem is probably most straightforward out of the three. You just straight up do what the problem asks you. You iterate over each photo, you get the average, and then you check if the average is in the photo. And so, since there are O of n squared different photos, and you can easily check each photo, you can take the average of all the numbers, and you can check if the photo contains that number in O of n time. So the overall complexity is O of n cubed. And that will be fast enough. However, I also want to discuss an O of n squared solution. For O of n squared, we can basically do more efficient looping. So what I mean by that is, let's say we've just considered this photo. Then, let's say the next photo I want to check is this next photo. Well, the sum doesn't change very much, right? We can just take the sum of this previous photo and then add 3 to it. And so what we can do is we can kind of calculate whether or not a photo is valid while iterating over the photos at the same time. And I will show off how that is done in the code. So that would bring it down to O of n squared. Although this is not necessary to solve this problem since n is only 100 and O of n cubed will also work. So let's look at the code now. So I'm going to go ahead and do my usual inputs, my imports. Right. And now let's see. So we read in n, and then n space separated integers for each of the petals. And now what? So now let's just go ahead and I'm going to iterate over each of the left endpoints. So the left side of the photo. And now here's what I'm going to do. I'm going to go ahead and maintain two things. I'm going to maintain the sum, and I'm going to maintain a Boolean array of whether or not we've seen each of these values. So here, I'm going to go ahead and create a Boolean array called seen, and it's going to be of size 1001. It's 1001 because in the problem, let me see, it states that the petals are only of size at most 1, or the flowers are only of size at most 1000. And now I'm going to iterate over each of the right endpoints. So this is the left endpoint of photo, and then the right endpoint of photo. I'm going to iterate over each of the right endpoints now. And so based on this, I'm now considering the photo from L to R. So what do? I add this sum. Yeah, so I add this flower to the sum, and I also mark this flower as being contained inside this photo. And now I can go ahead and see the size of this photo is going to equal R minus L plus 1. And then we can check the average. Now, one thing you might want to do here right now, you might think, okay, in order to calculate the exact value of the average, I'm going to use like decimal values with double. However, I don't recommend doing that. There's an easier way to check if the average is contained. Because we know that if the average is some decimal number, it's not going, or some fraction, it can't possibly be in the photo because we have no decimal inputs, right? All of the original flowers are integer values. Yes, all the original flowers are integer values. And so we only care if the average itself is an integer value, or in other words, if the sum is divisible by the number of elements or the size of the photo. So if the sum is divisible by the size of the photo, then we have the average is now the sum divided by the size. And now if we have seen the average, so if there exists a photo, or a flower with the average size, we increase our answer by 1. And at the very end, I will print the answer. And this actually works in, this is actually going to be n times 1000. So that's slightly more than like n times n for the maximum case of n equals 100. But that's okay, because that's still fast enough for this problem. So let's go ahead and run this. Let's see if we get the right answer. 6, that is correct. All right, let's submit this. All right, so that's going to be it for the second problem. That's how you do it. Thank you for watching.